more here. So it says, which of the following describes the roots of the polynomial function of that? So I have f of x equals x minus 3 to the power of 4 times x minus 6 to the power of 2. So I have these two things, and it's saying I have these functions here. These are all, or sorry, I have these statements here, and they're all talking about multiplicities, right? So it says here a negative 3 with, I'm going to say m equals 2, and 6 where m equals 4. B here is negative 3 is m equals 4. 6 here is m equals 2. This is all m equals multiplicity simply. 3 is m equals 2. Negative 6 is m equals 4. And D here is 3, m equals 4. And 6 is m equals 2. So, okay, so I have to figure out, okay, what is multiplicity? And what am I doing with those things here? So it's saying multiplicity is we're talking about the degree of what we have, like for example, we have a high order polynomial. We have something that's to the power of, in this case, 4 times 2 here. We can simply, what we can do is we can break this function into two parts, right? We can say there's this function here and this function here, right? Sorry, you can't see that. It's this function here, right? So I have x minus 3 to the power of 4. This is simply a quartic function. And what it does is, in quartic function, I have the x-intercept for this quartic function has to be, if I set this to 0, it has to be positive 3, right? Positive 3 is indeed a root in this thing here. And the multiplicity has to be 4, right? And again, it's a quartic function with the x-intercept of 3, which means this here is my correct answer. This here automatically makes this my correct answer, right? D is my correct answer here. As it's my x-intercept is 3, has a multiplicity of 4, which means it's the exponent here is 4, which means so that's the multiplicity. And if I separate this into x minus 6 squared, if I set this to 0, my x-intercept is obviously positive 6, and the multiplicity here is 2, right? It's squared, right? So again, you can think of these as separating them two functions, but when we combine them together, you get a function that's kind of that's a lot weirder, right? You have 4 times 2. This here would equal, if I'm this is now I am multiplying exponents, so this here is my polynomial is in order of 8, right? And in the order of 8, in the higher order of whatever, an 8th polynomial here, my roots of those ones is I have a quartic looking multiplicity at 3, and I have a quadratic multiplicity at 6 here. So in this case, D here is my correct answer. And let me just check their answer here. So so D is correct. That's good. We're given this polynomial. Since we know the roots are the x-intercepts of the functions, we can set this to 0. That's good. And then they said this, right? So like I said before, x minus 3 to the power of 4 equals 0. So x equals 3. That's awesome. And the x minus 6 squared equals 0, with 2 here is 3 as well. And so the root here is 6, and the multiplicity is 2. So that's good. So this here is a great solution. And analysis. I wish they kind of connected. They connected the question to the higher order polynomial that is presented in the question, and this would have been a 8th order polynomial. 8th order polynomial having x equals 3 and 6 as a root, as roots, where x equals 3 would have multiplicity of 4, and x equals 6 having multiplicity of 2. I think I misspelled multiplicity. Yeah, of multiplicity. There we go. Great solution to answer. This solution here is correct.